Once again, we'll be solving some rational equations. So remember in the last lesson, we said we're going to multiply everything by the lowest common denominator so that the fractions cancel out. So we're going to go along the same thinking process, but if we look at this first type of problem, notice we have two whole numbers on either side of the equation, so I would probably isolate the fraction before I did anything else. So 3 over x plus 2 equals negative 2. And then it's easy to see, to get rid of the fraction bar, you're going to multiply both sides by x plus 2. And the x plus 2's cancel out on the left, so you have 3 equals negative 2x minus 4 when you distribute. And then when you solve, you're going to add 4 to both sides. So 7 equals negative 2x, and x will equal negative 7 over 2, which if you plug it into your original there, it will not give you 0 in the bottom of the function, so you are good. I want you to take a minute and try the example you tried. Hopefully for this problem, you did get x to equal negative 2. Okay, so for this next example, notice finding the common denominator is not as simple as it once was. So we're going to alter our steps just slightly. Okay, so the first thing that we are going to want to do is we're going to want to factor our denominators. So notice for 5x minus 20, there is a greatest common factor of 5. So we'll do 5 times x minus 4. The middle denominator is already factored, and x squared minus 16 in that third denominator is the difference of squares, which factors to x minus 4, x plus 4. Okay, so our next step is to identify the common denominator. Our LCD in this case is we have to account for the 5, we have to account for the x minus 4, the x plus 4. And the one on the right is already x minus 4, x plus 4, which is noted in our lowest common denominator. So our next step is we're going to multiply both sides of the equation or each fraction by the lowest common denominator. Okay, so again, we're going to write our common denominator next to each fraction. Okay, so now we are ready to reduce our fractions. So notice in the first group, the 5 and the x minus 4's cancel. So we're left with 4 times x plus 4. In the middle fraction, only the x plus 4 cancels, and we're left with plus 5 times x minus 4, and then times the 1, but 1 times anything as itself. So we can leave that off. And on the far right, the x plus 4, x minus 4's cancel, and we're left with 1. Okay, so what's left for us to do next is to solve for x. Okay, so when we solve, we'll distribute the 4 through, so 4x plus 16, distribute the 5, plus 5x minus 20, and that equals 1. So what we'll do next is we'll combine like terms on the left side. 9x minus 4 equals 1. And then we will add our, oh snap, and no one caught my mistake. There's a 5 here, right? So instead of a 1, it's actually a 5. Whoopsies. Okay, so we're at 4 to both sides, now that we're back on track, and we'll have 9x equals 9, or x equals 1. Now, when we check for extraneous solutions, if I plug 1 into the original first denominator, do you get 0? No. What about the middle one? No. What about the last one? No. So we can circle our answer. I want you to take a minute or several to try this example you try. Okay, so hopefully for this example, you did get x to equal negative 29 divided by 3. Let's look at another example. Again, we want to make sure our denominators are factored as much as they possibly can be. In that first denominator, notice x minus 3 is already as reduced as it can be. And the same with the middle one, but I'm going to change the minus 1 to a plus negative 1. And our denominator on the far right, factors of are x minus 3 and x plus 2. So that means our lowest common denominator must include an x minus 3 and an x plus 2. So that's what we will multiply each fraction by. Okay, so once we do that, we're ready to start reducing the fraction. On the far left, the x minus 3's will cancel, and we're left with 2 times x plus 2. In the middle, the x plus 2's will cancel, and we're left with minus 1 times x minus 3. And on the far right, notice the x minus 3x plus 2's cancel, and we're just left with 4. Now we're left with an easier equation for us to solve. 2x plus 4, make sure you distribute the negative to both terms in the middle, minus x plus 3 equals 4. Combine like terms, so x plus 7 equals 4. And notice we do, when we subtract 7, we get x to equal negative 3. However, when we check our work in our example, did I make a mistake somewhere? Nope. Yep. So when we check our example, I'm not going to get 0 in this first denominator. I'll get negative 6 and negative 1 in the second. And the same thing is true with that third. Now take a minute and try the example you tried. Okay, so for this last one, it is no solution. And when you do get x equal to 4, notice when I plug 4 back into the original, I do get like 2 divided by 0 plus 1/8 equals 16 over 0, which is impossible. So this one is no solution. That add to give me negative 1. Ooh. Time to try some. The end.